Hey, this is Horner, and we're going to look at 2002 B3B in front of our live studio audience. Okay, here we go. So to start this one, we need to do a verb chart, and so we're going to put V, I, R, P. And we're going to list each one of the bulbs. So we've got bulb A, bulb B, and bulb C. And remember, bulbs are resistors. They slow down the current, and they will take some of the voltage. And so our total is down at the bottom. So there we go. Notice that your total voltage for this one is 9 volts. Our resistance in letter A, so here's bulb A, is 3. Our resistance in bulb B is 6. And our resistance in bulb C is 3. It does say that this switch is closed. Remember, a switch opens and closes a circuit. A closed circuit allows electricity to go through. An open circuit does not. And so it's kind of like a bridge allowing cars to go along the line. For this one, the first thing we need to do is recognize that we do have right here a parallel circuit. So this is bulb B and C. So I'm not going to use the numbers, I'm going to look at the letters. Here we go. And we need to figure out what is the current in bulb A. To do that, we're going to find the total resistance, and we can find the current in the whole circuit, and that will be the current in bulb A. Let's go ahead and use our equation. 1 over Rp is equal to 1 over the resistance in B plus, oops, that didn't go, plus 1 over the resistance of resistor C. So resistor B is 6 ohms plus resistor C is 3 ohms. So our common denominator here is 6. And when we get done, we get 3/6. And that's for 1 over Rp. So our total resistance in parallel, it's a little slow here, oops, there we go, is equal to, and then our answer here is 2 ohms. In order to find the total resistance then, now that we know that these two together are 2 ohms, we can place this here. Now we have just a series circuit. So we're going to say the total resistance is equal to 2 plus 3, and that would be equal to 5 ohms. Now we have the total resistance. We can use our good friend Ohm's law, which is the current is equal to the voltage over the resistance. This is how it's listed on your AP Physics 1 equation table. So you won't see V is equal to IR. You'll see this instead. Our voltage, remember, is 9 volts. So I'm going to put a 9 here. Our resistance overall is 5 ohms. So remember, we want to probably put that here. So we've got 9 volts, we've got 5 ohms, and if you divide those, make sure you don't leave fractions. We actually want 1.8 amps. And that is the answer to part A. So that would be 1.8 amps. The next question says, which light bulb is the brightest? We want to know which of the light bulbs is the brightest. So brightness, remember, is the power for each bulb. So let's go ahead and find the power in each one of the bulbs. So we want the power in A, we want the power in B, and then finally we want the power in C. Our problem is we need to figure out what is the power in A first, and to find the power in A, we need to know the current in A. So we know that the current in A, the current in A, we need to use the total current. So we're going to put 1.8 up here. And we take 3 times 1.8, and we end up with 5.4 volts. Now if I want to find the voltage in this part of the circuit, it's the same for each one. So I'm going to take 9 minus 5.4, and that gives me 3.6 volts for each one of these. So I took the 9 minus the voltage in this bulb, which is, we found it to be 5.4. It's thinking about it. And that would give us the voltage for each one of these, which is 3.6 in each one of those. So now we can use our equation V squared over R for each one. Our voltage in bulb A we said was 5.4, and we need to square that, divided by the resistance, which is 3. And this one gives us 9.72 watts. For letter B, you already know the equation. We're going to do 3.6 squared divided by 6. And for letter C, we will do 3.6 squared divided by 3. So this one gives us 2.16 watts, and this one gives us 4.32 watts. So when it says which one's brightest, you're going to say A is, my pen's really slow for some reason, the brightest. And my question is, did we justify our answer? Yes, we sure did. We said it is the brightest because it has the highest power. In the next part, it says the switch is opened, and it wants us to check the approximate spaces below, tell whether the brightness of each bulb increases, decreases, or remains the same. So what I'm going to do here is get rid of all the writing that we had, and we'll move it down a little bit, and let's go ahead and do another VRP chart. So our VRP chart for this one is V, I, R, and P. Boy, this is really slow. It's confused, I guess. So we have V, we have I, let's put in our R and our P. And this time, the switch is open. So when we open the switch, notice on our diagram here that we no longer worry about this part of the circuit. So now we just have a really nice, easy, simple circuit. Okay, and it's just a series circuit also. So we have a nice, really easy series circuit. Let's get rid of this junk right here. Come on now. I was thinking about it. Ah, there it is. And we are going to do our little VRP chart because I think that'll help us see what's going on. So we've got letter A now and letter B. We don't have to worry about bulb letter C because there's nothing going to it. So here we're going to say this one decreases, and it's because no current is going through. So because no current's going through, bulb goes out. So the bulb goes out for letter C. So that one you don't have to worry about. Our total here, we know our total voltage is 9. We know that the resistance of A is 3, of B is 6. So the total here is also 9, which means our current is 1 amp. If we know the current for the whole thing, we also know the current for each one of the bulbs. Now we can find the voltage, and consequently, oops, come on now, 3 times 1 would be 3 for power, 6 times 1 is 6 for the power here. They want us to figure out what happened to the brightness of bulb A. So for bulb A, it actually decreases, and they want us to explain why. And it's because the power for this bulb, P-O-W-E-R, come on now, it's too slow. Power went from 9.72 to 3 watts. So because our power went down, so power we can say decrease from 9.72 to 3. So that's a great explanation. They will understand that. For the next one, the brightness increases for bulb B because the power, thinking about it, power goes from 2.16 to 6 watts. So that power increases. And that is the end of this problem.